Hey guys, what's going on? It's Danny, and today we're going to be solving LeetCode number 5, longest palindromic substring. This question just asks, what is the longest palindromic substring? Okay, so what does that mean? Alright, the substring is just a group of the string, so some combination of the letters that are continuous, like these two or these three or all of them or one. Okay, palindromic, it's going to be palindrome, so it'll be the same forwards and backwards, and then the longest, so the longest palindrome is a substring of the string. Okay, a couple of requirements we got to meet. How might we think about this? Well, let's just look at the test cases first. So we have BABD, kind of just bad. CBBD. Okay, yeah. So that's a palindrome. I mean, that's a palindrome. I mean, does it really tell us anything though? I mean, well, wait. This one's B and B, but then this one's B and B, but there's like an A in the middle. There's only one of those. But, okay, yeah, but that doesn't matter because it's nothing to reflect to, so that element doesn't matter. Okay? So there's two different types of palindromes. There's an odd and an even one. Okay, that makes sense. Now, how are we going to find, well, what if the first thing we do is we find every single substring, check if they're palindromes, and take the greatest? I mean, that has to work, but it's going to be kind of big. So to find every substring, that's just n squared, right? We have to check all the 1 length, then all the 2 length, all the 3 length, all the 4 length, all the way on. And that scales at a growth rate of n squared. And once we have every substring, we have to find if they're a palindrome and then compare them. So palindrome, how are we going to find if it's a palindrome? Okay, well, a word like race car is a palindrome, and there's going to be 2 ways we can define it, find if it's a palindrome. We could use a stack, we could use 2 pointers, or we could use numerous other approaches. These are the 2 that came to mind for me. I mean, others might come to mind for you. So, stack, that's going to look like putting elements into the last in, first out. We'll put in the first half, skip the middle element, and then compare it to the last half. So, C and C, pop the C, A and A, pop the A, R and R are the same. Okay, that's a palindrome with a stack. Now, how would we even do 2 pointers? Well, we could do pointer here and here, and then slowly move in. Right, because, I mean, if all of these are the same all the way in, it has to be palindrome. And wait, the same thing is the true on the way out. If we were to go in the in and go on the way out, if these are the same as a palindrome, and so on and so on. Okay, so that's how we find if it's a palindrome. We do any of these, and those are all kind of O of n. You're pretty much accessing every element. But that's O of n cubed, okay? Well, that's a solution. We brute forced it, but is that going to work for 1,000 test cases? I mean, maybe not. Let's see if we can come up with something better. So what could we fix about this? I mean, what is wasting time in our solution? Right, we're checking all the substrings, checking if they're palindromic, and then comparing them. But, what if, I mean, I feel like we're checking all these substrings that aren't even close to palindromes, like R and A and C, like those just aren't palindromes. Why are we checking those? They're redundant. What if there was a way to guarantee the substrings we were checking were already palindromes? Okay, well, what if I'm iterating through the palindrome? What kind of structures could I use to determine if they're a palindrome as I go? Well, at each element of a stack, I would need to know what's after it already, so that I might know with 2 pointer. I mean, well, I could start at each one and then slowly move outwards, and that would also create all substrings. If I go left to right and then slowly move out from each, but what if I could stop it early? What if I get here to this A, yeah, this is a palindrome, and then I look out, I see R and C aren't the same, and then I can just end it. Wait, that saves that whole call. I don't even have to waste time on that. And then, for example, if I was looking at this C, I go out, they're not the same, and then I save going out again and again and again, and I can save all this time by guaranteeing they're palindromes and only checking those, right? And well, I don't even really need to check if they're palindromes. In fact, I'm only checking the subsequence. Okay, so we can keep going if they're the same, and then we know we're working with palindrome. Now, I think there's a solution. So how would this work? We get rid of this whole O of n. It's just n squared finding these things, but this only checks the odd ones. How do we check the even ones too? So we have a string like this. How would we check the well? What if we had a pointer here and here at the start, essentially splitting it down the middle like this? Okay, wait. For each string, we could split it down the middle between, because these two could be and these two could be, but then we could also split it down the very middle of each indice, because we could treat this as the middle, check the outside. Hey, we're checking, that's O of n right there, and that's expanding at a rate of O of n. That's going to be n squared. Okay, that's cool, awesome. Okay, O of n squared, that's not that bad. Does it work for this? Okay, yeah, it doesn't really matter if they're digits or letters. In fact, it doesn't matter what they are. We're just comparing the two sides. So we're not really storing much either. Okay, I mean, is there any way to solve this? Let's think. Is there any way to get O of n faster than, well, n log n, that's in between, but at log n reminds me of like binary search, and it's not sorted. So I don't really see a way to get log n here, but yeah, what if we try to get O of n? If we have a word like this, I mean, the one pass is impossible, so we get a two pass, where we're like, but I mean, what information can we store about this to make it O of n? We would need to go through it once, store it, and then go back through determining stuff. We can make hash map of an array list of the indices of the different elements, or we could use a stack to go back through it, or maybe some kind of genetic programming, I don't know, but I don't think it's going to be possible. I think the solution we have is good, so maybe let's try throwing that into code. Okay, so we know our solution, we're going to go left to right through it, so let's just start with our for loop right away, right? 0 as long as I is less than plus, okay. And then we remember our word like race car, and we need to check in between it, like this, the space, but we also need to check this is the middle, okay? Well, for each I, we're checking each element. What if we checked one in front of it as well? So we check this R and the space for each pass through. Okay, so we can expand at I, and we can expand, well, we're just expanding at I, we're expanding with 2 pointers at I, and here we can expand with a pointer at I in, I guess I plus 1, because we can check a pointer here and here as well, okay. So if we expand there and there, what could these methods return for us? Well, let's just start with this expanding method. How are we going to expand there? Well, we would need the actual string S, in indice left and in indice right, the 2 pointers, okay? Well, here, let's make sure we have the access to the string in this method, okay? Now, we have the string 2-pointer approach going outwards, kind of reminds me of like a while loop, right? Because we need the 2 conditions of, as long as the left indice is greater than or equal to 0, so as long as the left one isn't out of bounds, and I mean, as long as the right one is less than the length of the array, if that's also not out of bounds, so as long as these 2 are true, what can we check? Well, we can see if the character at the left pointer equals the character at the right pointer. Well, how do we solve from here? I mean, okay, so we have the left and the right. If they're the same, then we can just go outwards with each. Okay. Okay, and then we can keep expanding out, and this is just going to go out and out and out and out. Now, how are we going to figure out what the length of this is? Like, what are we actually returning? So for each expansion, the length of the longest palindrome for that. So we could return something to the left and right. So the right element, the right's going to be greater than the left, so let's do right minus left. Now, left is like indice 0, and right is indice 2. Do we want to include them both? I mean, if this is the left and this is the right, and this is the longest palindrome, 2 minus 0, 0 and 2, wait. Well, that's length of 2. Maybe we should, If C and R aren't the same, that's when the loop terminates. So that means that the pointer is pointing here and here, but these are wrong, which means we're 1 more in. So if this is saying that the length of it is 2, if right minus left is 2, if we do minus 1 more, that's the actual length of it, because we're 0, okay, because we're not including the same one. So we can return that. So the expand methods work. This gives us the, what it does give us, this gives us, I guess, just the expansion rates. So this is kind of like the odd expansion rates. And then what are these? These are kind of like the, I guess, even expansion rates, right? And then what else? I mean, we should probably have some kind of global variable. I mean, what are we going to be editing? What are we trying to return? This palindromic substring. Oh, we're just returning the actual string, so it's not just a length. We need to have the whole substring. Well, I mean, we could store the substring each time, but that's creating a new string object each time, which also isn't very good. What if instead we could find a way to store the integer indices at the start and the end? So we could have the starting indice,
and an ending indice. Okay, yeah, so we can sort of start and the end, and then we just take that substring, and that's going to be our final answer. So in fact, right now we can even type in what we're returning. We're just returning s.substring from the start to the end plus 1 because of the inclusive exclusive. Okay. We have this now. Well, we have our two things. Which one do we care about more? I mean the number is just, out of the two of these, I mean, we only care about the one that's greater. It doesn't even matter what they are. So let's just store them into a variable, and then what can we do with that? Well, we have this number, right? How do we know if we need to change these values to it? And how can we ensure that this new length is longer than start? Well, if this new number is greater than what? The end minus the start. That's the whole length of the string. If it's greater than the end minus the start, what does that tell us? Okay, well, that means that the start has to be equal to the starting of this string. So if we start at I, and we go back by the max length, okay, well, that's where the string starts, and then the ending of the string is just starting at the middle and going forward halfway. So just to clarify, the way this is working is we're finding the start, and we're going forward by half of the length of it, and then we're going also backwards by half the length, and that's our start and our end. Okay, these are here now. I mean, we have a return statement. I mean, what could we really be missing? Okay, well, let's run it and let's see what happens to our code. Okay, it runs. Okay, if we submitted it, it should work now. Let's see, is there any test cases we maybe missed? No? Awesome. Submits. Cool.